All right, so we are live right now. Okay, so we are live. So welcome back. I welcome all of you to this amazing platform of Tutee Learning. So today we're going to start again with the ongoing topics on coordinate geometry, that is going to be straight line. So the initial two lectures which I have taken so far on the coordinate geometry was basically on the basic portion of coordinate geometry, right? Now today the lectures that I am going to discuss is going to be discussion on the parts of the straight lines. So beginning of which I'm going to start with discussing about a few locus, right? Or what is the concept of locus and how do we come across the equation of locus or any general locus, right? So that will be the first and foremost agenda of this today's discussion, and following that we'll try to discuss about some of the important forms of the equation of straight lines, right? So let us start with the discussion on it. And before I start, I hope that you have already solved these 5 homework problems and you're already able to solve it. So if you have any questions in any of this question, please let me know, or else we shall discuss these problems, or maybe I will show you the answers, or I will list the answers in the comment section. Okay. All right. So with that, let's get started. So as I start today, let me first of all quickly discuss about the important topic of locus, right? So, what is basically meant by word locus, right? Now, in coordinate geometry, you will be always coming across this particular term called as locus, right? Now, what is this particular concept of locus? Let us try to understand. So, this locus or the word locus actually means that it is the equation of the curve which is moving under certain condition, or maybe from a given point, or maybe from a given condition, right? So I can say that let us say any general point P which is given as some variable coordinate h comma k. Now if I say that this particular point is rotating or moving in a particular plane such that its distance from the fixed point, let us say a fixed point as alpha comma beta, this is a fixed point. Okay, this is a fixed point which is known. This is a fixed point, whereas this h point or h comma k, or this p point, is a variable point. Okay, is a variable point, right? So this is a variable point, and I'm saying that this particular point P moves such that this distance of this point A and this point P is a constant. So whenever this kind of point is having a constant distance from a fixed point, that is something like of a circle. So this is kind of a circle, right? So thus equation of this circle, or the equation of this particular curve which is traced under this particular given condition by this variable point is nothing but it is called as the locus, right? So therefore I can define locus as the curve which is described by a point which moves under a given condition or conditions. Okay, there may be only one condition or maybe more than one condition as well, and that is called as locus. I hope this is clear to all of you. Okay. Now, there are certain equations, or there are certain fixed methods or steps to basically find out any general equation of locus. Okay, so if I give you any problem where you have to find out the equation of the locus of any given point, some of the standard steps are as follows. So I'm attaching some of the steps. So these are the following steps that will help you to formulate the equation of locus of any given point. So if I talk about the locus, so the equation of locus of any point, so in order to find out the equation of locus of a point is a relation which is satisfied by the coordinates of every point on the locus of the point. So the following steps that we need to follow are is that first of all, assume any point, let us say h comma k, and that particular point whose locus is required to be found out. Now, please write the given condition in the mathematical form involving h and k, and then try to eliminate the other variables if you have, try to, and then once you eliminate the variables, if there are, then finally the only step is to replace h with x and k with y in the following results obtained, and therefore you will obtain the result for the given locus. I hope these steps are pretty simple, right? So maybe I will discuss about some problems in order to understand this particular concept of locus, right? So let me ask you some problems. Okay, so let me give you a simple problem to begin with in the class. So let us say, let us take a very simple problem. So this is a very simple problem that we have to find out the locus of a point that joins the following point given as minus 5 comma 1 and 3 comma 2 such that it subtends a right angle at the moving point. So we have to find the locus of that particular point. So how do we solve these questions? The simple step is that whatever point is not known to you, first of all, assume that point as P, and that is given as h comma k. So first of all, let us assume the variable point or the point whose locus need to be found out be h comma k. So this is the moving point, right? This is the moving point. Now, if you try to understand from the question, it is said that find the locus of such point P, which is subtending at angle of 90° by these 2 points, right? So it is said that so that it join of minus 5 comma 1 and 3 comma 2 subtends right angle. So let us say this is my known point minus 5 comma 1 point A, and let us say point B is 3 comma 2, and this PA and PB forms an angle of 90° at this point P, right? This is pi by 2. So how do we form this? Again, very simple. We'll try to utilize the concept of perpendicular lines, or maybe we can use the concept of what we have already studied in our previous discussions of vector algebra, or maybe I can use the simple Pythagoras theorem to solve this problem. So in this condition, if I use the Pythagoras theorem, so I will easily obtain a condition that is AB square is equals to AP square plus BP square, right? So I will easily obtain this particular condition, that is AB square is equal to AP square plus BP square, right? Because the right angle is formed at point P. The right angle is formed at point P. Now, if I apply this condition, I will get the following result as follows. So, if I try to find out my AB square, that is going to be 8 square plus 1 square, and that is going to be equals to, so this particular part is going to come out as 65, right? Now 65 is equals to, this particular part will be h plus 5 whole square plus k minus 1 whole square plus h minus 3 whole square plus k minus 2 whole square, right? Now this is my given variable equation, right? Now over here, if you see that there are no other variable except h and k, so we don't need to eliminate anything, just we need to write the equation in terms of h and k, and then the final equation will be found by replacing this h and k with x and y. So the ultimate step at the end, once you remove all the equation from the variables, then you have to just replace this h and k form into their equation form, that is in terms of x and y. So that is basically going to be x square plus y square plus 2x minus 3y minus 13 is equal to 0. So this is the equation of the given locus. Now if you are quite familiar with the locus of circle, this is the general equation of circle only, right? And also you can also verify this concept if your point A and B, if your point A and B are the opposite point of the diameter, that any point on the axis or the arc of the circle will always obtain 90° at the diameter, right? So any point, that is point P, will subtend 90° at the diameter, right? That is what the main concept also regarding the properties of circles, right? So you can also relate back to that particular form as well. So what you can see is that the geometry is relevant to the algebra, and the algebra is also proving the same geometry, right? So I hope this is clear to all of you. I hope this problem is clear. Please do let me know if you have any questions, any queries. Okay. I hope this is clear to all of you. Please let me know if you have any questions, any queries. Okay, so I'm going to a live chat. As I can see, no one has any queries. So maybe then I will start to discuss about another problem, or maybe I will ask you to solve this problem. Okay. Now this kind of problem is quite an interesting problem, and yet an important question for JEE Mains, right? So if you turn on to your JEE Main previous year papers, you will definitely find this particular problem. Okay. So please try to solve this problem. This is a very important problem and a very fundamental and relevant problem for your JEE Mains examination. Okay. So please try to solve this problem. Please try to solve this problem. And with this part, I will definitely try to give you some of the problems for homework as well, right? But before that, please try to solve this problem, okay? Please try to solve these problems. Okay, so I hope you have read through the problem. The problem is very simple. The question says that there is a rod of a length L and its sides slides with its ends on the two perpendicular lines, or you can consider two perpendicular walls, right? Or the case of a wall, there is a rod which is sliding along the wall, right? That is what is said. So you have to find out the locus of the midpoint. Locus of the midpoint. So let me first of all formulate the problem. Okay, so if I draw the two perpendicular lines like this, let us say this is my wall boundaries. Okay, these are very relevant problems, especially you can imagine this problem to that of a ladder. Okay, just basically being inclined on a fixed wall. So there is a line like this, and let us call this point as A and this point as B, and this length of this line is basically given in the problem as L, right? And let us say this is the point O, right? So we have this particular formulation. So, and also this is perpendicular to each other, right? Now we have to find out the locus of this midpoint. So in order to simplify this problem, let me assume this OB line as the x-axis and OA line as the y-axis, right? So I have to ultimately find out the locus of the midpoint. So that is irrelevant under my choice of the any coordinate system. So I can consider this as my coordinate system and I can solve the problem. Now, in order to do that, let me assume some distances. Let us say this particular distance is B, and let us say this particular distance is A. Okay, this particular distance is B, and this particular distance is A, right? As mentioned over here. Now, from this one equation I can obtain as, that is L square plus L square is equal to A square plus B square, right? This will be a right angle triangle, and I can easily obtain this following relation, that is L square is equal to A square plus B square. And let me label this equation as equation number 1, right? Now if I try to write the coordinate of point B, that will be just B comma 0, and coordinate of point is going to be 0 comma A. So by considering this, the midpoint midpoint of the line AB is going to be just B by 2 comma A by 2, right? This is the midpoint, right? By using the section formula, you can easily obtain this relation by dividing it in the ratio of 1:1. So we will get B by 2 comma A by 2. Now what you have to also understand that this is my given locus. So what I have assumed that I have assumed my variable point as B by 2 comma A by 2, right? So we have to find out the locus of the midpoint. So what if I interchange this equation and write in form of this, then I will be easily able to obtain the following equation of the locus, right? Okay. So what I'm going to do over here is that, so from this result, what I can try to modify, and I can, so from the equation of 1, if I try to modify and write something like A by 2 whole square plus B by 2 whole square, and then whole multiplied with 4, and that is equals to 4 times of L square, right? I can write this following equation as follows, right? So I multiplied 4 on both the sides, right? And then what I will obtain is that now I have already obtained my known given point like this. Now please note what I'm doing over here is quite a crucial process, is that I'm multiplying 4 on both the sides, right? And then in order to remain the same problem, what I'm basically trying to replace is that I'm trying to assume this as my h comma k, and then I will replace this over here. So if I do that, I can replace it with 4 times of hs square plus 4 times of k square is equals to L square. Okay, is equal to L square, right? I hope this is clear. Right, now we have already seen that if I have removed my variable, because L is the constant point, it is not the variable. So h and k are the variable, and after I obtain the relation eliminating all other variables except h and k, then I can relate my equation of the locus in terms of x and y, where I will just replace h and k with x and y. So what you will see that this is again going to be an equation of the circle, right? So therefore, if you observe carefully a ladder which is basically placed on a wall, and if it is sliding down slowly, then if you try to track the midpoint, if you try to observe the rotation of the midpoint, what you will see that the midpoint is definitely going to attend some locus of a circle, okay, whose center would be at the origin also, right? So this circle will be something like a center at origin, something like this, okay. But unfortunately the ladder won't definitely go over here, so it will be sliding something like this, okay. So it is basically saying that the midpoint will definitely try to follow this particular curve along the circle. Okay, so if you observe the midpoint of the ladder while it is falling down as it's sliding slowly, you will see that it will definitely be completing a circle. Okay, so that is the basic understanding of the locus. Okay, so with this part, I think you are probably now ready to basically solve some homework problems. So maybe what you will do is that I'm giving you some problems for practice. Okay, so you try to solve these problems and let me know the solution of these problems in the upcoming lecture. Okay, so maybe what you can do is that also if you are able to solve it quickly by today itself, you can definitely comment on this particular video as well, right? Is this part clear to all of you? Is this part clear to all of you? Uh, Tushar Dubey, straight line cons. Tushar Dubey, what is your question? I can't understand what you're writing up there. Line concept. Okay. So please correct the whatever you're asking, and then I can discuss. Okay. All right. So now let us start with our basic understanding that we wanted to start with is the concept of straight lines, right? Now, along with that, however, there are certain more things to also understand is the shifting of the origin and the rotation of the origin, right? So those are the two important concepts that I will definitely cover as then when the need arises, right? So maybe in the upcoming lectures, I will be trying to discuss a bit on the rotation of the axis. So what happens or how does your coordinate systems get changed if your, let us say this is my x and the y axis like this, and if I have to represent that in new coordinate system which is basically given as x dash y dash, such that this particular angle is rotated by something angle theta. So in this case, how am I going to represent this x dash y dash, that I'm going to discuss as by this particular formula, right? Okay, so therefore any point in the new coordinate frame can be given by this matrix equation, right? So therefore we'll discuss about this rotation of axis concept. Okay, so this is a concept of rotation of axis. Okay, so what happens if I rotate my axis? So if I just rotate my axis, what happens? So we'll discuss this in the upcoming lecture. Okay, so for the time being I'm just omitting this particular concept, right? So maybe if you're interested, you can also go about and look into the definition of it or maybe the derivation for this particular part. However, we'll discuss about the concept later. Okay, so definitely we're going to discuss about it. So any point can be given as this x comma y, and that particular point is also can be given as x dash y dash, right? So that is the main fundamental concept. Okay. So that is how you can represent from x dash y dash to x comma y, right? So by using this particular equation. I hope this is clear to all of you. I think when we are basically rotating by and counterclockwise direction, the minus should come over here. Okay, the minus should come over here. Yes. Okay, so we'll definitely going to discuss about this particular problem. However, let us first of all, for the time being, let us now proceed with the understanding of straight lines, right? Now, the straight line concept is quite a fundamental concept and you must have already covered in your basic classes. However, it is quite important to get a recap on it before we start with the actual parts. Okay, So if I talk about straight lines, by the definition of straight line, I can define it is a locus of a point or a curve that every point on the line segment joining any two points is going to be on the curve, right? So if I draw a line in such curve such like that, so if I take any 2 points and the line segment is definitely going to lie on the same curve. That is the definition of a straight line. Okay, now, however, there are certain two things important, especially for straight line, that is a concept of slope or gradient, right? That is a concept of slope or gradient of a straight line, right? So if I talk about slope of a straight line, so if I try to represent the straight line in the coordinate axis frame, that is my x and the y axis, such that the line is given something like this. Okay, let us say this is my line over here. Let us call this point as A and this is my B. And whatever this angle is made by this line with the positive x-axis, please note this is with the positive x-axis. And if I take the tan of that particular angle or tangent of that particular angle, that is the definition of what is called as the gradient of the locus. Okay, so the locus of the gradient is defined as that tangent of that particular angle which the line makes with the positive x-axis. Okay, and please note that the angle has to be taken in the anti-clockwise sense. Okay, is this part clear to all of you? Now, by using this particular concept of the slope of two lines, we can also get an idea on what is the angle between two lines, right? So let us see how we actually formulate that particular problem in order to find out the angle between angle between two lines. Okay, so let us try to understand the concept of angle between two lines. Right. So what is the concept of angle between two lines? Let us try to understand, and we will try to relate this angle between two lines by the slope of the individual lines, right? So let me first of all draw the situation in order to understand this particular form. So let us call this x and y axis, and let us take out two lines. Okay, let us take two lines like this. Let us say this is my line A, this is my line AB. Let us say this particular point of intersection is B, and this particular point is C, right? Now, if I say that this line AB is making an angle theta 1 with the positive x-axis, and the line CB is making the angle theta 2 with the positive x-axis, right? So therefore, the angle between the line is basically given by this particular angle theta, right? So the angle between the line is this particular angle theta. Now our main concept comes over here, that how am I going to calculate this particular angle theta, right? That is my question. So if I try to understand from this particular triangle, this is very simple and very clear that I can relate this particular angle theta as theta 2 minus theta 1, right? So this is very simple. The opposite angle is the sum of the interior opposite angle, right? So the exterior angle is the sum of the interior opposite angle. Like theta 2 can be given as theta plus theta 1, right? So the exterior angle of a triangle is the sum of the opposite interior angles, right? So from here, I can easily obtain theta as theta 2 minus theta 1, right? Now, if I try to apply the concept of tangent on both the sides, so if I take tan of theta, then that will be equals to tan of theta 2 minus theta 1. Now, if you try to take tan of theta 1, that is the slope of the line AB, that is M1, and let us say tan of theta 2 is the slope of line BC, that is M2, right? So if I have the slope of the line like this, then I can apply this particular result, and if I try to expand this by the compound angle formula, then we know that tan of A minus B is given as, so over here it will become tan of theta 2 minus theta 1 divided by 1 plus tan theta 1 into tan theta 2, right? It will become something like this. So from here, once I evaluate this particular result, it's going to be coming out something like this. Now I will just put it the slopes in this following relation, and I will get something like m2 minus m1 divided by 1 plus m1 m2, 1 plus m1 m2, right? So this is going to be my tan of theta. Now from here, this theta can be easily obtained by finding out tan inverse of m2 minus m1 divided by 1 plus m2 m1. right? Now please note that sometimes it might happen that the angle or the m2 minus m1, this difference comes out to be negative, right? So if this particular difference comes out to be negative, that is nothing but the theta would come out as to be an angle which is greater than pi by 2, right? Or which will come out to be an obtuse angle, right? However, to avoid that particular confusion, what we do is that we put a mod over here, right? Because we always want to find out the acute angle between the two lines, right? I hope this particular part is clear to all of you. Okay, because we might see when I basically talk about the angle between the lines, so the angle between the lines like this can be given, this is theta and this particular angle will be pi minus theta, right? So if I do the tan of theta or tan of pi minus theta, the result is going to be the same except with a negative sign. So in this, if I do tan of pi minus theta, it is going to come out as minus of tan theta. So therefore what you can see is that if I can try to find out both the angles, however, in order to be on the safer side, please try to put a mod over here, right? So this is a mod put over here so that you always calculate for the acute angle, right? I hope this part is clear to all of you. I hope this part is clear. Arjun Singh, hi. Hi Arjun Singh. Is this part clear to you? Is this part clear? Please let me know in the live chat. Is this part clear or not? Okay, so once this particular part is clear, then we can also understand two important things, that if I have the concept of, if I have to develop the concept of parallel lines, the angle between two parallel lines is either 0 or pi, right? So parallel lines or maybe any integral multiple of pi. So therefore I can consider theta as 0, and in this case what I will obtain is that for parallel line the slope is the same, right? Which is very obvious, right? But for perpendicular lines, for perpendicular lines, if I have two perpendicular lines, that means my theta would be just pi by 2. So if I have perpendicular lines, the theta would be pi by 2. And in this case, I will have tan of theta to be not defined. And that happens if and only if this product of m1, m2 is coming out to be minus of 1. So this is a very, very important concept that we'll be using up many times in our discussion, right? So this is a very, very important problem, right? So generally when I will be asking you for the equation of the perpendicular line, you will be using this particular concept of the product of the slope of the two lines would be equal to minus of 1. I hope this result is clear to all of you, right? And it's a very simple result, right? Please take a note of this. Please take a note of this. Okay. So therefore, definitely you can try to solve some problems regarding this. But let us now come to understanding the different forms of the line equation, right? And from there, let us also try to understand or the concept of intercept, right? So first of all, if I try to write, so we have already seen the slope of the line. So if I try to write the equation of any straight line in the slope intercept form, so there is one more term over here that is involved, that is called as the intercept, right? So if I try to talk about the intercept, so intercept can be seen something like, so if you have a line, let us say this is my coordinate axis x and the y axis, and let us say this is my line. Okay, let us say this is my line I have, and let us call this line as a and b, right? So therefore this particular length of the line with the origin where the line is intersecting the x-axis is called as a x-intercept, and this particular point where the line intercepts the y-axis from the origin, it is called as a y-intercept. So this particular distance is, let us call this origin as O. So OB is the y-intercept and OA is the x-intercept. So intercept is just a concept of distance or the measure of the distance of the point where the line cuts the x and the y-axis from the origin, right? So if the straight line cuts the x-axis at A and the y-axis at B, then OA and OB are known as the intercept on the x and the y-axis respectively. I hope this is clear, and therefore we are now ready to write any general equation of line. So let us say this is my line, or let me also draw a better line. So this is my x and the y-axis. Okay, and then if I try to formulate a line something like this, which is making an angle theta with the positive x-axis. So therefore, if I represent any point as x comma y, and this particular angle is also theta, now what I'm going to do is that, what I'm going to do over here is that, first of all, let me consider any point on this line as P, right, as x comma y. And if I have this particular point x comma y as any point on the line P, then, and my slope is given as m is equals to tan of theta, m is equals to tan of theta, right? Now if I try to replace this particular thing, and or maybe if I try to represent this length, so maybe I will take this point somewhere over here, let us say this is point Q, and then I will try to form this small triangle, and let us call this point as M, capital M, right? So in this particular triangle, in this small triangle that you can see, the point P is x comma y, this Q, and this is angle theta, and let us say this point P, right? So if I try to find out this QM distance would be simply given as x, right? Because my P is having the x coordinate as x, and the y would be given. Now let us call this particular intercept on the y axis is given as c, So this particular distance of PM would be basically become equals to y minus c, right? So y minus c, and now if I apply the tan of theta, which is basically going to come out as y minus c upon x, y minus c upon x, and therefore if I replace this tan of theta with m, I can come up with the result of mx plus c, or maybe I will write it like this, y is equal to mx plus c. So therefore this is the general equation of a straight line in terms of the slope and intercept form. I hope this is clear. So from this particular intercept form of the line, why do you know the slope and the intercept, you can form the equation of line. Similarly, if you know the slope, and any one point on the line, that is x1, y1, and you know the slope of the line, then without knowing the intercept also you can find out the equation of the line like this, that is called a one point slope form, and that is basically like this, right? Where you can assume any known point, any variable point on the line as x comma y, and then again you can form this triangle. Let us call this A, let us call this P, and let us call this B. So again in this triangle APB, where this is 90 degree at B, so again I can use the concept of tan theta, and I can formulate this particular equation of the line. I hope this is clear to all of you, right? So this is the equation of the line which passes through one particular point x1, y1 and having a slope of m, right? Is this part clear to all of you? Is this part clear? So this is the basic concept that you need to remember in order to formulate any general equation of line, right? So what I will do is that after this discussion, I'm going to give you one problem to find it out. Okay, so we have already discussed the concept of medians, right? So therefore I want you to basically solve this problem. And I know that we have not discussed what happens if I give you 2 points, right? If I give you 2 points, how am I going to find out the equation of the line? I haven't discussed it, but I know with these two discussion of the slope intercept form and the 1 point and slope form, you can definitely come across defining the equation of the line which is passing through 2 points, let us say x1 y1 and x2 y2, right? So maybe you will be easily able to do that, right? So the initial part is quite simple. Try to find out a slope first of all from here, and once you obtain the slope and you already know 1 point of the line, and you can easily formulate the equation of the line, right? So this will be something like y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x1, right? So if you apply this, you'll be easily able to get the equation of the line in the 2 point form, right? So please try to apply this and try to solve this problem and let me know the answer in the comment section. So this is the homework for today's particular lecture. So along with the 7 problems that I've already given you in the locus sections, okay, so there are 7 more problems over here. Please take a screenshot of this, okay, and this is also your homework problem for the today's class. And in the following lectures, we are definitely going to discuss about the other important forms of equation of lines, and then we are going to solve some of the standard problems that are very, very relevant for the JEE Mains examination, right? And then following that, we are definitely going to enter into the properties of straight lines. So that is the way forward ahead of us. And with this particular part, I thank you, and I thank you for your wonderful attention in this lecture. And I hope you do well in your examination, and please make sure that you make short notes and keep on revising them, right? So with this, I wish you all the best. Thank you.